In this video, we're going to break down all of the exponent laws and why they work. So here is a summary of a few exponent laws that we're going to be using. So we'll go through these one by one and understand where they come from. So let's start right here with the product rule. So what does 5 squared times 5 to the power of 3 times 5 mean? Well, if we were to write this out, and write it in expanded form, we know that 5 squared is just 5 times 5. And then we have times 5 to the power of 3, which is just 3 5s multiplied together. And then we have times another 5. So how many 5s do we have? We have 1, 2, 3, 4, 5, 6. So we have 5 multiplied by itself 6 times. So this expression can just be simplified to 5 to the power of 6. So the question is, what is a shortcut? How can we get from here to here? So we know if we take a look at the exponents, what we're really doing is we're counting the 5. So this exponent tells us that we have 2 5s here, we got 3 5s here, and the exponent here, invisible, is 1. So a shortcut would be if we just take our base, which is 5, and then just add the exponents, because that's going to count the 5s for us. So 2 plus 3 plus 1. And that's going to give us 5 to the power of 6. So that's our first rule. Our first rule is called the product rule, and this is how it's written. If we have something with the same base multiplying together, we can combine it into one term by just adding those exponents together. Let's take a look at another rule here. So let's take a look at the quotient rule. So instead of multiplying, what if we divided these guys? So what would this look like? We've got one big fraction bar. We've got 7 3s on the top of the fraction. So that's 5, 6, 7. And at the bottom we have 3 3s. So let's simplify this. Well, I know that 3 divided by 3 is 1, so if I can cancel out a 3, I'm going to cancel out a 3. So 3 divided by 3 is 1. I've got another 3 divided by 3 I can cancel out, that's 1. And I have a third 3 divided by 3 that cancels out. So what am I left with? I'm left with 4 3s at the top of the fraction. So 3 to the power of 4. I could put this over 1 if I wanted to, because really there's a 1 there, but that's fine. We know that that's equivalent. So I'm left with 3 to the power of 4. So really what I'm seeing is I'm going to check what the leftover is. How many 3s do I have left over? So what would be a shortcut here? What could I do with those two exponents when we divide? Well, we could subtract. So this is the same as if we were to just take our exponents and subtract them. Sorry, there's not 3 minus 4. 7 minus 4, it's 7 minus 3. And so let's finish this up. It's going to be 3 to the power of 4. So here's how to do it in long form. The quotient rule, the shortcut is when we're dividing two terms that have the same base, we can just subtract the exponents. And that's what this rule is right here. When we're dividing two things with the same base, we can just subtract the exponents. Let's try another rule, power of a power. So what does this mean? This means 4 squared all to the power of 4. So if I were to write 4 squared, it would be 4 times 4. And if it's all to the power of 4, that means we're going to write this 4 times. So I'm going to do again, 4 times 4. And again, 4 times 4, and one more time, 4 times 4. So really, all this is just 4 multiplied by itself. How many times? 8 times. So a simpler way to write this is 4 to the power of 8. So what's a faster way? What's a simpler way? 4 squared 4 times. How can I get 8? Well, I can just multiply the exponents. So when we have an exponent raised to another exponent, a shortcut is just multiplying the two exponents, and we get 4 to the power of 8. So that's called the power of a power rule, and we can see that it's summarized here. When we have a base raised to an exponent, and it's all raised to another exponent, all we have to do is multiply these two, and we get the new exponent. Let's take a look at a fourth rule. What if we have a 0 exponent? Here's what I mean. If we take a look at this guy here, and we write this out. So we have something divided by the same exact thing. So if we just expand this out, we've got 6 2's on the top. So 1, 2, 3, 4, 5, 6. And we've got 6 2's at the bottom. 1, 2, 3, 4, 5, 6. So how can we simplify this? Well, 2 divided by 2 is 1. This is 1, 1, 1, 1, 1. So they all cancel out. What's left over? Well, something divided by that same thing is going to be 1. So where's the 0 exponent? Well, another way we could simplify this is using the quotient rule. We know if we've got the same base with division, we can just subtract those exponents. So this is just going to be 2 to the power of 6 minus 6, which is 2 to the power of 0. So both of these things have to be accurate. This thing has to equal 2 to the power of 0, and it also has to equal 1, which means that these two are the same thing. Anything to the power of 0 means that we must have divided something divided by its same thing. So if we divide something divided by the same thing, it's obviously going to give us 1. And an equivalent expression would be something to the power of 0. So anytime we see anything to the power of 0, it's going to be 1. And that's what this 0 exponent rule here is. It doesn't matter what the base is at all. If it's to the power of 0, it's always going to equal 1. And if you forget, you can just throw it into your calculator. Try a half to the power of 0. It's all going to be 1. Any number to the power of 0, 1,000,005 to the power of 0 is going to be 1. Okay, let's take a look at the last couple. So here we've got something in here all to the power of 3. So this 3 is touching the bracket. That means that everything inside the bracket is going to be to the power of 3. So if I rewrite that this is 2a to the power of 4 all 3 times. So how could we simplify this? Well, think about this as, if I don't write this with brackets, so let's say if I erase all of these little brackets here, and I just put in dots. It might be easier to see. So instead of brackets, I'm just going to put in dots. So it's easier to see that we can multiply all these guys together. So I'm going to put, here we go. So I'm going to put times, so it's the same thing. So can we see what our number would be, our coefficient? We've got 2 times 2 times 2. What is that? That's going to be 8. And then we have a to the power of 4, so think of that as a, times another 4 a's, a, times another 4 a's. How many a's in total? We would have 4, 8, 12. So this guy here just simplifies to that. What's a faster way that we could do it instead of writing it out 3 times? Well, we could apply this cube to everything inside of the bracket. So we could apply it to the 2, and we could apply it to the a to the power of 4. So if we simplify that, 2 to the power of 3, 2 times 2 times 2, we already calculate that, it's a. And here we know we have the power rule, power raised to another power, so we're just going to multiply those guys, and it will be a to the power of 12. So we get the same answer as if we were to write it out. So the rule is that if we have an exponent outside of a bracket, and in that bracket are multiple things like coefficients, letters, we have to apply that exponent to everything inside the brackets. Now this only works for products or quotient. This does not work. So I'm going to put a big X through it. X, let's change it up to, sorry, instead of 2, it will do 2 plus a to the power of 4 to the power of 3. We cannot do this, cannot do this rule. Okay, so there's no rule that says I can put that 3 in there. We know what to do with a cubed in this case. We've got to write this bracket out 3 times, and then we're going to have to FOIL. So this only applies to a product or a quotient. Okay, so it could work for something like this. If we have 2 over a to the power of 4, that's fine too. Okay, so it can work for a it can work for a product or a quotient, not addition and subtraction. So we've got two more rules down. Power of a product. We have two things multiplying inside a bracket with an exponent outside. We can apply that exponent to everything inside. And then power of a quotient, same thing. If we've got a quotient inside, so it's two things that are dividing, we've got a power outside of the bracket, we're going to apply that power to everything inside. And our last rule that we're going to go through is negative exponents. Okay, so let's take a look at what this means. We're going to do this in two different ways. So I'm going to put this underneath. Okay, so let's just expand this out and figure out, oh, no, it's not, this is not 4, it's 5. Let's just figure out what this is going to equal. So we've got 5, 5, 5, 5. So we've got 4 5s on top, and then we have 6 5s down below. 1, 2, 3, 4, 5, 6. Okay, how many 5s are going to be left over? Well, we've got 5 divided by 5 is 1, 1, 1. How many are left over? There's 2 5s, but where are they? They're at the bottom of the fraction. So what must be up here? A 1. So we've got a higher exponent at the top than the bottom, and so in the end we have leftover 5s, but they're bottom of the fraction. What if I were to take the same example and use the quotient rule? So we know what to do with those two guys. We're just going to subtract them. So it's going to be 5 to the power of 4 minus 6. Which is going to be 5 to the power of negative 2. Both are accurate answers. This is an accurate answer, and this is an accurate answer, which means that they must mean the same thing. So anytime we get a negative exponent, it does not give us a negative answer. If you were to put 5 to the power of negative 2 into your calculator, you will not get a negative answer. You're going to get a decimal answer, 0 point something. So anytime we get a negative exponent, all that means is that 5, or whatever this base is in the wrong place. So there are 2 5s, but they don't belong here. They belong at the bottom. So anytime you do get a negative exponent, what you got to do is you have to move that term from its place. So if it's at the top of a fraction, you got to move it down to the bottom of the fraction, like this. So this means there are 2 5s, but they don't belong up here. They belong down there. So that's our final rule. Oh, that's not it. Where's our final rule? Here we go. Negative exponents. So anytime that we have a negative exponent, it doesn't mean it's a negative number. It means that that term is not that base is not in the right place. It belongs in a either at the bottom of a fraction if it's negative at the top, or if it's negative at the bottom, it belongs at the top. So let's practice. In the next video, we're going to actually apply these exponent rules.